Okay, the next thing we are going to learn is about Coulomb's law. What is Coulomb's law? This law is a popular law anytime we are talking about electrostatic. So before we state the law, let's talk about who discovered it. Now, there's a man called Charles Coulomb. A man named Charles Coulomb. Charles Coulomb is a French physicist, and this man proposed the relationship between two charged bodies. And this time, he called them after his name, which is called the Coulomb's law in the year 1785. So Charles Coulomb actually discovered the relationship between two charges, and he called the law after his name, which is called Coulomb's law state, and see the condition behind it. Okay, so coming down to Coulomb's law, what is Coulomb's law? Now, Coulomb's law is the origin of many mathematical expressions we have in electrostatic. So picking it, Coulomb's law states that the force of attraction or repulsion. I need to explain that very well. Anytime you hear the word attraction or repulsion. According to Benjamin Franklin actually states a law between charges. And what law was it? Now, he called that electrostatic law. And what is that? He said anytime we have a positive charge and a positive charge, that means these two positive charges will not attract one another, rather they repel. He call it repulsion. Why are they repelling? Due to because they have the same kind of charges. And also it's applicable to when we have a negative charge and a negative charge. So due to because they have the same kind of charges, according to Benjamin Franklin, which he called the electrostatic law, it means those charges will repel. There will be what we call repulsion. When it comes to a situation whereby the charges are alike, meaning looking different, so at this case, they will attract. That means there will be a force of attraction. So according to Benjamin Franklin, he said that when we have charges of the same like, they repel, but we have charges of different like, they attract. So due to because of that, it gave us a basis of understanding of what we want to talk about Coulomb's law. So Coulomb's law again states that the force of attraction or repulsion between two charges is directly proportional to the product of their charges and inversely proportional to the square of their distance. Now, this law has an expression. Let's see the expression. Okay, talking about the expression of Coulomb's law, a quick one. Coulomb's law made us understand that there is a force of attraction. So let's say force of attraction F is directly proportional to the product of the charges. So that means when we have charges is always symbolized as letter Q. Please note that charges is symbolized as letter Q, and the same Coulomb's law states that the force of attraction is also inversely proportional. Force of attraction is inversely proportional to the square of their distances. Now, if you look at this law, we can try to combine them. So when I say force of attraction, the same force of attraction or repulsion is directly proportional to the product of their charges, and that same force of attraction is inversely proportional to the square of their distances. So that means we can try to bring them together. In bringing them together, we are going to have something this way. So as you all know in mathematics, anytime we have this kind of symbol produce a constant. So that constant is going to have an equals to, and the constant is k. So we have q1, q2, then r squared. Please, this is the relationship of Coulomb's law. This is the relationship of Coulomb's law. So let's call this our equation 1. So another thing we love to talk about is what we call the k. The k there is not just ordinary k. The k there is called constant. And that constant is always equals to 1 over 4 pi epsilon naught. So a quick one, let me quickly tell you about Q here refers to charge, and that Q here refers to charge. Then the R square refers to distances. So please, there are some words we are going to be using in this our learning. At first, I told you that this K there represents what? Constant. Or we can say force constant. But where I need to pay attention to is the value of this epsilon naught. They actually call it epsilon. And they call it naught. I don't know whether that's the right spelling, but basically in physics we call it permittivity of free space. This symbol epsilon naught is called permittivity of free space. So that's symbol there. So when you combine this value of K into what we have in the equation, we should be having something like, since we have the force of attraction, F is equals to K Q1 Q2 over R squared. So therefore, we're going to have that F is equals to 1 times Q1. Okay, we can have it this way. Q1 Q2, then 4 pi the epsilon naught, then R squared. So in this case, this is the formula we use for electrostatics and majorly for Coulomb's law. So this is the equation 2. Now I'm going to tell you the values of each of them.